the different critical voltages that are getting appear in different regions of this voltage transfer characteristics of the signal, right? So in region A, we have a critical voltage which is called as VOH. So what do we mean by VOH? VOH means the maximum output voltage for logic output for logic 1, which means that we know when we apply logic 0, we are going to get logic 1 when it is inverted. Okay, when it is getting inverted. That is the basic stuff. When you apply 0, you get 1, right? Okay, the what you get 1, but what is the maximum voltage level of that 1? Is it 5 volt or is it 4.5 volt? It may be 4 volt, but you are getting somewhat voltages closer to this range. That is why we are declaring that as logic 1, right? But what is the exact maximum output voltage? That is going to be your VOH. I hope you got this. So first thing is you have to understand that VOH. The next thing, we have another voltage here. This voltage is called as VIL, and this voltage will be found at this slope, which is equal to -1. The slope at this point should be equal to -1, and at that point you can find an input voltage which is nothing but VIL. So what do we mean by VIL? VIL is nothing but the maximum input voltage which can be interpreted as logic 0, which can be interpreted or which can be taken as logic 0. So what do I mean by this? See, for example, again the inverter logic is when you apply 0 you're going to get 1, but what is the maximum voltage which can be taken as 0? Okay, for which you are getting 1. What is the maximum voltage which can be taken as 0? Say for example, if I apply 0 volt, I'll be getting 1, logic 1. If I apply 0.5 volt, I'll be getting logic 1. Because this will be considered as logic 0. If I apply 1 volt, it will again be considered as logic 0. So for that, I will be getting 1, logic 1 as the output. If I apply 2 volt, it will again be considered as logic 0. For that, I'll be getting logic 1 as the output. So up to which voltage I can apply, that will be taken as logic 0. Okay, up to what voltage which can be taken as logic 0. Okay, say for example, if I apply 4 volt, that will be taken as logic 1, right? So for that you will be getting logic 0 as the output. So this is not VAL. Okay, VAL must be lesser than that. Say for example, up to 2.5 volt, I can apply whatever if I apply, that will be taken as logic 0, and for that only logic 1 will be the output. Okay, so up to 2.5, whatever I am applying, those voltages will only be taken as logic 0. For example, 2.4 volt, 2.3 volt, 2.2 volt, 2.1 volt. Up to 2.5 volt, whatever I apply, that will be taken as logic 0. And for logic 0, you will be getting logic 1 as the. So this is, then VAL can be taken as 2.5 volt. So that is the example I want to take. So maximum input voltage, which can be taken as logic 0. If you cross VAL, that will be taken as logic 1. Very simple. If you cross VAL, so say for example, if I add a 0.1 to VAL, and if you apply this voltage, that will be taken as logic 1 only, and for which you will get logic 0 as the output, right? So the maximum voltage for which can be taken as logic 0, that is VAL, right? Beyond which if you apply, that will be taken as logic 1. Very simple to understand, that's it. Okay, so that is VAL. And you have this threshold voltage, right? That is VTH. Threshold voltage beyond which it is logic 0 and above which it is logic 1, right? And you have another input threshold voltage here, that is VAH. There also the slope is -1. That is found in region D. In region D, there is another input voltage which is called as the critical voltage, the VAH. That is again where the slope is -1. So let me explain VAH. VAH is minimum input voltage for or which can be interpreted, which can be taken as logic 1, which can be taken as logic 1. It's again exactly opposite to VIL, which can be taken as logic 1, right? For example, if I apply 4 volt, it will be taken as logic 1. So for which if you invert it, the output will be logic 0, right? If I apply 3.5 volt, that will be taken as logic 1, and if you invert it, that will be given logic 0. If you go lesser than this, that will be taken as logic 0, right? So what is the minimum voltage? 3.5 is the minimum voltage for this example. That is the minimum voltage which will be taken as logic 1. Okay. So you always have a range of voltages that will be taken as logic 1. In that, what is the minimum? That is called as VIH. That is called as VIH. Okay. So your input band will appear like this. This is the input band. From 0 to up to maximum, you can apply up to VIL. All these range of voltages will be taken as logic 0, and from VIH up to 5 volt VDD, that is the maximum you can apply. All these voltages will be taken as logic 1, right? This is with respect to the input, not with output. This is with respect to the input, right? So that is the minimum voltage after which all the voltages will be taken as logic. There is a maximum voltage below which all the voltages will be taken as logic 0. And there is a dead band here. You can see this band is actually called as the transition band, where you cannot observe the output, right? It cannot be either logic 0 or logic 1. Okay, you cannot observe the output there. So there is a transition band between the logic 0 and logic 1 phase that you have to understand, right? So this is for a practical inverter. For ideal inverter, this transition band will not be there. VIL and VIH will be the same for an ideal inverter. Okay, I hope you got this. This is very important, and these are some of the characteristics that you have to understand in order to design any inverter. Now we will see some more designs of inverter in the upcoming videos. Thanks a lot.